Everyone, what's up? Welcome back to my tutorial channel. Daniel's here and today I'm gonna talk about risk management. This is my last video in the series of probability and SMP preparation. So in this video I'm gonna first introduce the loss distribution in insurance, then partial insurance coverage, how to model a loss random variable X, and how to model an aggregate claim. Now let's get started off with loss distribution in insurance. When someone is subject to the risk of incurring a financial loss, the loss is generally modeled using a random variable or some combination of random variables. The loss is often related to a particular time interval. An insurance policy is a contract between the party that is at risk, policyholder, and an insurer. Under this policy, the policyholder has to pay the insurance premium to the insurer, and in return, the insurer will reimburse certain claims to the policyholder. Modeling a loss random variable. Let's represent the financial loss. The expected value EFX is referred to as the pure premium for the policy and also the expected claim to the insurer. The utilized risk or coefficient of variation for a random variable X is square root of variance of X over expected value of X, which is equal to sigma over mu. Sometimes the insurance is not paid in full but partially. So to understand partial insurance coverage, we are going to consider three types of partial insurance coverage. The first type is to use deductible insurance. A deductible insurance specifies a deductible amount, say D. If a loss of amount X occurs, the amount paid by the insurer can be described as Y is the amount paid by the insurer. Y is 0 if X is less than or equal to D, and Y is X minus D if X is greater than D. This means if the loss is less than the deductible amount, then the insurer does not pay anything to the policyholder. Otherwise, the insurer will pay an amount of X minus D. So Y is basically the maximum between X minus D and 0. The expected payment made by the insurer when a loss occurs would be the expected value Y. Here from 0 to when X less than D, Y is 0. So when we take the integral, we can start at D. So the expected value of D is, we integrate from D to infinity, X minus D times the PDF of X. And this equal to integrate from D to infinity 1 minus the CDF of X at dx. In deductible insurance, we have two important categories. The first one is the franchise deductible. Y is equal to 0 if X less than or equal to D, and Y is equal to X if X is greater than D. That means if loss does occurs, the insurer will pay in full. And the second category is disappearing deductible. In the disappearing deductible, we're using two deductible amount, D and D prime. D is the lower deductible and D prime is the upper deductible amount. So if the loss is less than D, the insurer does not pay anything to the policyholder. If the loss is between D and D prime, the insurer will pay D prime times X minus D over D prime minus D to the policy. If the loss is more than D prime, the insurer will pay in full. Example, A large random variable is exponentially distributed with mean 1,000. A deductible 200 is applied before any insurance payment. Find the expected amount paid by the insurer when a loss occurs. So here, this is a partial insurance coverage using deductible rate 200. So the expected amount paid by the insurer when a loss occurs is we integrate from 200 to infinity x minus 200 times the PDF of x. Here x follow exponential distributors with mean of 1,000. So the PDF is e to the negative x over 1,000. The whole thing divided by 1,000. So another way to find expected value y is using the CDF. So this equal to integrate from 200 to infinity 1 minus the CDF of x at the point x dx. The CDF of exponential distributors would mean 1,000 is just e to the 1 minus e to the negative x over 1,000. 1 subtract CDF, we have simply e to the x over 1,000. And integrate this on 200 to infinity, we got negative 1,000 e to the negative x over 1,000 x from 200 to infinity. And the answer is 1,000 e to the negative 1/5. The second type in partial insurance coverage is to use a policy limit. A policy limit of amount U in the case that the insurer will pay a maximum amount of U when a loss occurs. Therefore, the amount paid by the insurer is y is x if x less than or equal to U, and y is U if x is greater than U. That means if the loss is less than the policy limit, the insurer will pay in full. If the loss occurs is greater than the policy limit, the insurer will pay the amount of the policy limit, U. And the expected payment made by the insurer per loss would be E of y is integrate from 0 to U x f of x dx plus U times 1 minus the CDF of x at U. This is equal to integrate from 0 to U 1 minus the CDF of x at x dx. It is possible to combine a policy limit and a deductible insurance. So if an insurance involves a policy limit U and a deductible D, then the amount paid by the insurer is y is equal to 0 if the loss occurs less than the deductible D. If the loss is between the deductible and the policy limit, the insurer will pay y minus D to the policyholder. If the loss is greater than the policy limit, the insurer will pay U minus D to the policyholder. Example: a large random variable is uniformly distributed on 0 to 1,000. Find the mean and the variance of the insurance payment if a policy limit of 500 is imposed. Here, first we set up the distribution of the payment. Y is the amount of payment paid by the insurer to the policyholder. So y is x if x less than the policy limit is 500. And if the loss is greater than or equal to 500, the insurer will pay 500. Here x is basically the loss function, the loss distribution, loss variable. Follow the distribution uniform. So the CDF of x is 1 over 1,000 if 0 less than or equal to 1 less than or equal to 1,000, and this is equal to 0 otherwise. So to find the expected value of y, we integrate from 0 to 500 x times with the PDF of x dx plus U is 500 times 1 minus capital X of U which is 500. And the answer is 375. This is the expected value of the amount paid by the insurer. The expected value of y squared is integrate from 0 to 500 x squared times PDF of x plus u squared, which is 500 squared, times 1 minus CDF of u of x at u. The answer for ex squared is 166.667. So the variance of y is ex squared minus ex whole square. The answer is 26,042. Modeling a large random variable x. Type 1. The complete description of x is given. In K, x is continuous. The density function f of x and the distribution function capital F of x is given. In case x is discrete, the probability function is given. For example, x is equal to k with probability of q, and x equal to 0 with probability of 1 minus q. This means if the loss occurs with probability of q and the loss does not occur with probability 1 minus q. Another example of a discrete loss random variable is the following example of annual expenses for a family over a 1-year period. Here is a table showing a discrete loss random variable of annual expenses. So the amount of annual expenses can be either 0, 200, 400, 800, or 1500 with probabilities 0.1, 0.1, 0.3, 0.4, 0.1 respectively. That means for the first type, the distribution of the loss is given completely. For example, for a 1-year annual insurance, a policy for a family, we consider the following model for annual claims X. Here we have the amount of annual expenses can be either 0, 200, 400, 800, or 1500 with probabilities 0.1, 0.1, 0.3, 0.4, and 0.1 respectively. The question asks for the expected value of X and variance of X. This question is basically just like random variables. So to find expected value of x, we multiply its value of x with its probability and then add them together. So expected value of x is 610. Expected value of x squared is 533,000. And variance of x is ex squared minus ex whole square, which is 160,900. The second type of this model is when the probability Q of a non-negative loss random variables and the conditional probability distribution B of loss amount given that a loss has occurred is given. So that means here we use conditional probability distribution. Let's say W represents for whether the loss occurs or not occurs. W is 0, that means there is no loss occurring. W is 1 if there is a loss occurring. The probability that a loss occurs is 1 minus Q, and the probability that the loss does not occur is Q. The loss amount X is X equal to 0 if there is no loss occurring, and X is equal to a random variable B follow distribution FB, which is given if the loss does occur. So here B is basically a this is a conditional probability distribution. It's just happen when the loss does occur. So the expected loss amount is E of X is 1 minus Q times E of X given W equal to 0 plus Q times expected value of B. And expected value of X given W 0 is just 0. So the first term is disappearing. So this equal to Q times expected value of the random variable B. Ex squared is 1 minus Q times Ex squared given W is equal to 0 plus Q times expected value of B squared. This is equal to Q times expected value of B squared. And the variance of x is Ex squared minus Ex whole squared. This is equal to Q times expected value of B squared minus Q squared times expected value of B whole squared. And this is equal to Q times variance of B plus Q times 1 minus Q times expected value of B squared. Modeling the aggregate claims. The individual risk model. The individual risk model assumes that the portfolio consists of a specific number, say n, of insurance policy with a claim for one period on policy I being a random variable xi. Suppose that xi are mutually independent variables, then the aggregate claim is a random variable. S is summation of xi, that means the total insurance policy. The expected value of the aggregate claims is E of S. Expected value of S is expected value of summation of xi. This is equal to summation of expected value of xi. And the variance of the aggregate claim is variance of x is variance of summation of xi, which is equal to summation of variance of xi. If expected value of xi is mu and variance of xi is sigma squared, then the expected value of S is n mu and the variance of S is n sigma squared. Now let's consider this example. Two portfolios of independent insurance policies. Here the question gives you two portfolios A and B, and the question asks for the ratio variance of SA over variance of SB. So let's take a look at these two portfolios. In each portfolio there are two classes, and in each classes we have around for portfolio A, class 1, we have 2,000 policies. In class 2 we have 500 policies, and similar for portfolio B. And for each class we are given the probability of claim, the claim amount, which is the expected value. For the portfolio A, there is no variance. That means the variance is 0. So to find this ratio, we need to first find the two variance of SA and variance of SB. So let's look at portfolio A. The first class is policy. Variance of X1 is just 0.05 times variance of B1 plus 0.05 times 0.95 expected value of B1 squared. Here B1 is variance of B1 is 0 and expected value of B1 is 1. So this equals to 0.05 times 0 because variance is 0 plus 0.05 times 0.95 times 1 squared. The answer for the variance of the first class in the portfolio A is 0.0475. Similar for the second class in portfolio A, the variance is 0.36. So the variance of the aggregate claim A is 2,000 times with 0.0475 plus 500 times 0.36 because there are 2,000 policy class 1 and 500 policy class 2 in portfolio A. Similar for portfolio B, the variance of its policy in the first class is 0.00975 and the variance of its policy in the second class is 0.76. So the variance of the aggregate claims SB is 2,000 times 0.0975 plus 500 times 0.76. The answer is 575. So now we have found variance of SA and variance of B. Now we are going to find the ratio. So the ratio of the two variants of the two aggregate claims A and B is 275 over 575, which is 0.478. Modeling the aggregate claims. Another type in modeling the aggregate claims is using normal approximation. For an aggregate claim S, whose mean is expected value of S and variance is variance of S are known, it is possible to approximate the probabilities for S by using normal distribution. The 95 percentile of aggregate claims is the number Q for which probability of S less than or equal to Q is 0.95. If S is assumed to have a distribution with approximately normal, then by standardizing S, we have probability of S less than or equal to Q is probability of S minus expected value of S over square root of variance of S. This is less than or equal to Q minus expected value of S over square root of variance of S. This is standardization, and this probability is nothing but 0.95 because this is the 95 percentiles. Using the Z table, by the way, on the exam you're not allowed to use any calculator except BA second plus and TI-30XS multi-view. So you will have no way to find the Z-score without using the Z table. The Z table will be given on the exam. So on the Z table you are able to find the Z-score. The 95 percentile for standard normal distribution is 1.645. So that means Q minus ES over variance of S is 1.645. From here we will be able to find Q because the expected value of S and variance of S are given. So Q is 1.645 times square root of variance of S plus ES. Example 5. A portfolio of independent insurance policy is divided into 3 classes, and the insurer charges a premium Q that is the 95 percentile of the aggregate claims distribution based on the normal approximation. So here we are given an aggregate claims including 3 classes, and each class we have a numbers of policies. The question asks for the 95 percentile. So first we need to find the distribution of Q. Here Q follow normal distribution, which is have to find expected value of the aggregate. Here the aggregate claims follow normal distribution, so we need to find expected value of the aggregate claims and the variance. Let's look at the first class. The variance of its policy in the first class is variance of Xi, which is equal to 0.001 times variance of the policy. Here the variance is 0 because it's not included, plus 0.01 times 0.99, that means Q times 1 minus Q, times was expected value of B squared, and B here, expected value B here is 1. So the variance of its policy in this class is 0.0099, and the expected value is just 0.001. Similar for the other 2 classes, we have variance of its policy insurance in the second class is 0.0196, and expected value is 0.02. For its policy in the third class, the variance is 0.1536 and the expected value is 0.008. So the expected value of this aggregate claims is 1,000 times with 0.001 plus 2,000 times 0.002 plus 5,000 times 0.008. We got 90 for the expected value of the aggregate claims. And the variance of this aggregate claims is 1,000 times 0.0099 plus 2000 times 0.0196 plus 500 times 0.1536, and we got 125.9. This is the variance of the aggregate claims. So here's the thing, the aggregate claims follow normal distribution approximately, and we know the expected value and we know the variance. So to find the 95 percentile, Q is basically 1.645 times square root of the variance plus expected bias. So we got 108.45. So this is our last lesson in the series of probability, and I want to stress here that on the exam, we will for sure encounter many questions about risk management. So this chapter is one of the most difficult and one of the most important section in the study of S&P and probability. So that is everything for today. Thank you so much for watching my video. I hope you guys enjoyed my video, and I hope my series of videos have been helpful for you to practice for S&P seriously.